Hi, everyone, and thank you for joining us at Coalesce. My name is Bar, and I work on product here at DBT Labs. I'll be hosting this session. The title of this session is Stay Calm and Query On, Root Cause Analysis for Your Data Pipelines. And we'll be joined by Francisco Alberini, who is head of product at Monte Carlo. First, some housekeeping. All chat conversation is taking place in the Coalesce Root Cause Analysis channel of DBT Slack. If you're not part of the chat, you have time to join right now. Visit our Slack community and search for Coalesce Root Cause Analysis when you enter the space. I'm so excited to hear Francisco discuss this topic today. He was previously Senior Product Manager at Segment, where he worked for 5.5 years. Now at Monte Carlo, he focuses on leveraging best practices from DevOps and software engineering to surface and solve data issues faster, something we all care about here. We encourage you to ask other attendees questions, make comments, or react at any point in the channel. After the session, Francisco will be available in the Slack channel to answer all of your questions. I'm going to pass it over to you, and let's get started. Thank you, Francisco.
Awesome. Thank you so much, Bar, for a great introduction. I'm also super excited to be here and tell you a little bit about what we've been learning from the conversations we're having with our customers at Monte Carlo. So just a little bit more on myself. So I'm currently head of product here. I would say the majority of my time is spent talking to our customers around data quality issues that they're having, how to improve the quality of data over time, reduce what we call data downtime, and all of that in the idea of increasing observability to how data and how our data platform works. Previous to that, I was at Monte Carlo. I was at Segment. I was leading a product called Protocols, which was all around data quality and how to improve the quality of data coming into Segment. So I spent many years talking about the same issues that I'm talking about now with our customers. Also, the father of 2 boys. I just had a son 2 weeks ago. So you'll see my presentation might be slightly tailored towards what's top of mind for me. And I moved to Brooklyn last year, so I'm a hipster in training here. So yeah, so the idea of root cause for a crying baby. You might be thinking this is weird. Why is Francisco talking about crying babies? Well, one, it's top of mind for me. It's something that I've been thinking a lot of. And I think there's a lot of analogies into determining why a baby is crying around how to actually determine what's going wrong with your data. So normally, if my baby's crying, there's like a laundry list of things that I go through. And maybe his diaper is dirty, maybe he's cold, maybe he needs food. And then, of course, there's a long tail of other things that could be going on. But I think the majority of time, that list is enough to figure out and help a baby stop crying. And I think it's really similar in the data world. Actually, I think there's like the gist of what this presentation will be about is understanding that there is usually just a framework or a model that you can put in place. It doesn't have to be super complicated. It doesn't have to be extremely intense to be able to determine the root cause for your data issues. At Monte Carlo, we like to say good pipelines, bad data. I'm proposing that we change it to good parents, bad data, and that sometimes, yeah, maybe we're good parents, we have the best intentions, but we don't always figure out the issue. But anyways, so let's jump into a little bit of context setting around data quality and how do we think about things here at Monte Carlo. I'll probably start by saying the most obvious statement of 2021, and perhaps one of the more obvious things that we've heard a lot in terms of themes here at Coalesce, that everyone in the company is relying on data more and more, from finance to marketing to product to engineering, success, sales, etc. The real key differentiator among companies today is their ability to use data. And I think that's just a helpful framing, because when that data goes wrong, a lot of times I think we're left feeling like, I don't know what to do. If you're a data engineer, analytics engineer, feeling like I'm not sure where to start, especially if you're new to the team. I think this is a really key differentiator that we've seen a lot, in that I talk to a lot of data engineers that have the entire data platform in their head. So you might ask them, okay, there's an issue over here, or this particular table wasn't updated. They know immediately where to go. But as data teams are growing, we're thinking data engineer 3 through 10, or analytics engineer, the 12th data analytics engineer on the team. They're not as familiar with these systems, so it's much harder for them to know and determine the root cause, especially if they're on call. So I think all of these systems are predicated on that idea of what do I do? Where do I start? And then I'll note here, this whole concept, I think just from a vocabulary perspective, is what we call data downtime. I think it's helpful to name it and to say, okay, yeah, this is how we think about it. The idea of data being partial, erroneous, missing, and it's a real problem. Cool. Enough of talking about babies and setting the stage here. Let's jump into the meat of the presentation here and what we're going to go through. So I think one of the things that I've found to be really helpful is looking at the DevOps world and site reliability engineers or engineering as providing a lot of context on how to think about root cause. Fortunately for us, this is an industry that's been around for close to 20 years, thinking about how do we improve the quality of software and our systems that we are using to actually run that software. And there's all these different frameworks and models and great lessons that we can pull into the data world and borrow from. Things like source control or version control, so super common among the teams that we talk to in the data world, obviously using code. So it makes sense that we would want to borrow these concepts. Really simple anomaly detection models. This is super common among DevOps world, something that we spend a lot of time here at Monte Carlo thinking about. The idea of incident severity. So this is something that I've seen less commonly used among data teams, but just defining that an incident has a severity level. So if something is a SEV 0, it's like everyone in the company should probably drop what they're doing and figure out how to solve that issue. Whereas if something is a SEV 4, we can say, okay, maybe we don't need to fix that now, or maybe we don't ever need to fix it. But just defining severity levels is actually a really helpful way of prioritizing when to fix something or how urgently something should be fixed. Not something I've seen commonly used, but I think it's a really helpful model to incorporate. Testing frameworks, CI/CD, the ability to actually deploy code continuously and having kind of the safety and confidence to do that is super important. And then lastly, the measurement model. So there's a lot of great models and frameworks out there for how do we measure the quality of our software over time. So thinking about SLIs, SLOs, SLAs, we'll touch more on that later. But these are all really amazing concepts and frameworks that we can borrow from in the data world. Cool. And another thing here I'll touch on is this is a somewhat of a complicated concept, but I'll try and explain it really well. The idea here that code and most issues can be attributed to either code or operational environment issues in software engineering specifically. So it's either something in the code is broken or something in the operational environment broke. And because of those two things, what we can say is we can often start to understand that if there is an incident, let's say in the operational environment of one team, these really clear swim lanes that we've created in the software engineering world allow and create this world where the blast radius of a particular incident doesn't expand too broadly beyond just that one team. So if we have this incident, we can say, okay, the actual issue itself is contained because we have these clear swim lanes, we have these APIs, we have all these modularized models for how code is developed and deployed. And that makes for kind of a nice containment zone for any of these issues. However, in data, for all of the efforts that we have around data mesh and like productization of data, it's really hard to maintain that same level of rigor in kind of defining these different swim lanes and different containment zones for issues. So if we look at this diagram here, whereas before we have each team with their set of APIs and their code that's running in the operational environments. Here we have 3 different data teams. Let's say they also have code, they also have operational environments that they're executing, their DB2 models or whatever it may be. They're all interacting though with different schemas within usually a central data warehouse. Yes, this is like a full abstraction. I realize that this is different for every team and not a lot of teams don't follow this exact model. But I think in what we've seen in data mesh world is like the ideal case is that we have these really clear schemas for each different team and clear areas of ownership. But what I've seen is that often starts to break down because one team may say, oh, actually, I'm going to pull one table from this third schema and then maybe pull data from there and write to my schema 1 and create a little bit of a rat's nest or a mess here that's difficult to contain. And then, of course, we add in the analytics team, which now with things like dbt are able to also manipulate the data. So they're creating a little bit more complexity, more abstraction, more new tables being generated. And then we have the BI layer. So we have all these different data consumers, either through BI tools or maybe directly hitting the data warehouse, doing their job, using data to do their job. So we might say, similar to the early example in the software world, where we have an incident in this one particular team's operational environment, and we may think, oh yeah, of course, that team only interacts with schema 4, so we know that only really the BI users are going to be impacted by this. But because we have this kind of like references across teams, that incident could be impacting every single team. Basically, it becomes organization-wide. There's a really great blog post that I'm happy to share after in the Slack channel that explains this concept really clearly. But I think it's so important to understand that we're not just dealing with code and operational environment root cause, we're also dealing with data and like understanding that the complexity of data is increasing the complexity of this problem pretty significantly. And I think that blog post I mentioned is from Locally Optimistic by Brian. Again, I'll share that in the notes after. So hopefully that sets the stage. I think one other example that I want to share, I was talking to one of our customers, they're a big media company. And he was basically saying, it's like, the challenge that I deal with in this crazy model is that we have, for example, a data science team, they're now empowered to go and create their own data sets. And yes, they might create those data sets in their own namespace schema, but because it's in the data warehouse, someone else can very easily come along and reference that table and now build their own sub-process off of that and their own set of new tables and schemas. And like the sprawl of these tables and the data itself becomes very hard to maintain. And his problem was like, I can't control that, yet I'm responsible for that. So when that breaks, when that table that data scientists created for their own specific use case breaks and someone else is referencing it, they come to me. They come say, hey, what's wrong with the data here? Like there's an issue. I have no way to control that. I didn't create that table, and my team is not responsible for it. And I equate this to asking a DevOps engineer to say, okay, not just the master branch now needs to be tested and validated and correct, but every other branch that anyone has ever created in the code repo also needs to be vetted. And so that would be insane. That's very difficult. But we're somewhat, in a way, asking data platform teams to do that, to basically vet every piece of data that has been ever into or out of the data warehouse. And the complexity of that is really quite large. Cool. So again, hopefully that's helpful context setting. I find that concept just super fascinating, and I think a lot about how do we help our customers navigate that. But yeah, let's actually talk into what we do about this. One option, of course, we could always try harder. That rarely works, unfortunately. So let's jump in with an example. So let's say you get this wonderful Slack message. I'm sure many of you have seen this. If you have like an analytics channel, it's okay, I have to run this report. I'm seeing a huge increase in volume for this particular table. It's super important. I need this fixed right away. So there's a graph here. This is something that you would see in Monte Carlo. Okay, we have this big jump in volume. The way to think about root cause that we like to do is start to break down the problem into these three categories. This is why I spend so much time describing these things. The data, what can we look at in the data? What can we look at in the code? What can we look at the operational environment to very quickly determine the root cause? So the first step on the data side, if we dig into that, is to profile the data. So actually understanding what about these new anomalous rows, these extra anomalous rows, is unique. Is there a particular field that has a decrease in the uniqueness? Are we seeing additional fields that have a lot of null values, for example? These types of clues are really helpful for you to determine what is the root cause. If we see that there's a huge decrease in the uniqueness of a particular field, oh yeah, it's probably likely that duplicate values or duplicate records were added. That gives me a first clue to determine the root cause, and I usually have a better sense of where to go. Because if there is no distinctness issue, if there's no nulls, then okay, then let's move on to the next thing. But this is a great place to start. And then another thing here is actually going one step further beyond that, and actually looking at the correlation between those extra rows and the field values themselves. So I think we've seen this. I started my career in marketing. And I think this happened many times where we would run a particular campaign and then see this huge increase in volume from a particular source, let's say Facebook in this case. So you might see that all those extra records have come through, but we know that we ran a marketing campaign. So then we can say, actually, yeah, that was a fully expected anomaly. It was an anomaly. It was different than the past, but it was expected because of the actions that we took. So this is like a perhaps more sophisticated analysis that you can run, but something that you can do to better understand the anomalous records and see if there's any values there. A lot of this can be done through SQL, so just running like very basic SQL queries. I've seen some customers do that. And then in addition to that, Monte Carlo does a lot of this within our platform for our customers. And then the other piece here that I think is really helpful is to look at like the idea of lineage, or understand your concept of lineage and how tables are referenced across your pipelines. This is a graphical representation of that, but what we're seeing here is that this table events table at the very end on the right side has an anomaly or has a bunch of incidents associated with it. And if we look upstream, we can also see that there were changes, there were issues that were effectively causing this downstream issue. And I see this a lot, for example, a schema change. Let's say that I have a DBT model where I have a where clause filter that references another table. Someone comes along, removes the referenced field, basically deprecates that particular field or column. And now my DBT model fails or changes because of the fact that where clause is no longer active. It's no longer actually filtering the result set of records in the table, in the downstream table. So understanding and being able to look at your lineage, understand what are changes upstream that could have caused this ripple effect downstream was a really important part of the data root cause piece. Okay, so just a recap of the data piece. So we have profiling our anomalous records. So like looking at percent nulls, percent uniques, any changes there. Evaluating if the field values among anomalous records. So can we do kind of almost like a deeper level analysis to look at the correlation of those field values towards the anomalous records. And lastly, looking at lineage itself. So what happened upstream that may have caused this? And like I said, a lot of these are things that we propose or that we support in Monte Carlo, but a lot of it can also be done in your own environments. Like you can run these SQL queries. You can define what the queries are that should be run as part of like a run book or playbook, and then look at things like lineage, even within DBT, Airflow, whatever it may be. Cool. Hopefully that's helpful and clear. Let's move on to the code piece. So we systematically are creating our checklist, similar to what I do with my crying baby. The checklist here is to actually look at the code itself. So were there particular changes? And a lot of times, the nice thing about data is the codes, in many cases, at least specifically with DBT, abstracts into SQL. And then that SQL will usually provide a lot of clues around what happened here. Did something change? Did someone add a new filter or new where clause on a particular query that's populating this table? Or did someone change maybe the Python code in a particular Airflow job, and then that's caused this ripple effect? These are kind of like the table stakes for understanding where code may have caused the actual issue itself. And then another piece here that I found really interesting, this is a kind of like a heuristic that we came about just in our own internal dogfooding, but being able to actually map the query character length and look at that on a graph is actually, it's a really helpful and quick way to rule out a query change being the cause of a particular incident. So let's say that we have this DBT user executing a DBT job that runs every day. It's consistent. And all of a sudden we see, and this example here with these little triangles represent that the 3 yellow dots here, now we added maybe like 15 characters to a particular query, a DBT query that ran. And now that is actually the cause. That can be the root cause of the issue. We had, like I mentioned, a dog food example of this where one of our engineers was added basically a where clause or a limit, I believe it was, to a particular DBT query, accidentally pushed that into production. And then all of a sudden we see the volume of this particular table go from 30,000, which was expected, to about 500. Immediately, of course, you're thinking like 500, yeah, maybe that was the trigger to say if that's a weird number that all of a sudden the records would decrease by, must be the limit. But the fact that query change was actually the indicator, the reason that the issue happened. So I think this is something that's really helpful, a good heuristic for determining if your code is actually changing. Great. So from a code perspective, recapping, looking at the SQL code again, or the Python code, or the recent changes in the code that's generated the data itself, and then also that trick of graphing the query character length to determine if the changes actually did occur. For the most part, those queries change very frequently. So any types of small query changes are usually a good place to start in your root cause, or determining root cause. Cool. And then we'll lastly touch on the operational environment piece. Within your operational environment, the idea here of looking at errors, what errors could have occurred within the jobs that ran, were there permission changes that occurred? We see this all the time. Let's say in a warehouse, a particular table or schema, the permissions are changed and therefore causing issues with the DBT user or whichever user is being used to actually execute the queries. There could be network changes, port issues, scheduling changes. Let's say that someone goes in and changes the schedule of an upstream job, unknowingly changes and creates this downstream kind of ripple effect where now that upstream job was expected to be completed at 10 a.m. Therefore, my secondary job starts at 11 a.m., giving me 1 hour, but someone changes the schedule. All of a sudden, we have this kind of ripple effect of issues. And of course, performance. I think if there are performance issues, query execution times taking longer than expected, these are all things that can cause outages in your operational environment. Just going through the list is a really helpful way to figure out if that is the root cause. And then another piece here that I think is incredibly helpful, and it's an interesting one, the idea of just documenting what actually happened within the incident itself. I think we see this a lot in retros within the DevOps world or software engineering. And I think the reality, at least in my experience as a product manager, like these are usually pretty painful to do because you're like, oh, all this work, I have to go and document minute by minute what happened, what are the steps we took. And I think at the moment, it's hard to see the value of that because at the moment, there's no value, right? Like the fact that I'm documenting this, I'm not getting value from that. It's really only becomes valuable the next time that issue happens again, that you're saying, oh, of course, this happened 2 weeks ago. I remember exactly what we did. Great, I don't have to reinvent the wheel. I don't have to go through all of the root cause piece that we've talked about earlier. So I think this is just an incredibly important part to build into your workflows as a data team, is to say, okay, how do we build a lot of process around documenting what happened and why it happened and what were the steps taken to resolve that. And I think going back to my earlier point around the growth of data teams, so it's not just that first data engineer, the second data engineer that has the entire data platform in their head. It's all of the subsequent folks that join the team. Like this is an incredible amount of value for them to be able to go and reference and say, oh, look, yeah, I see that this incident or this particular pipeline, there's been 10 incidents in the last week. They all seem to be related to this one like crumbling piece of infrastructure that we need to resolve. Great, that allows us to focus our efforts on resolving that particular thing. So just a really important piece here of the puzzle is documentation. And then the beauty of the SLA, SLO, SLI model is something that we're really excited about. I think we're seeing a lot of customers start to adopt this. This is actually a screenshot of something that we've seen one of our customers build. The idea here of starting with SLA, which is a service level agreement, I would say this is like the holy grail piece. I don't think it's something that people should start with. I would usually say start with the SLIs, which are basically the indicators. What is an indicator of a system being broken? What can you programmatically measure and start to build graphs upon and metrics to understand, okay, is this something, this system particularly broken? Once you've defined those, once you've got the indicators, moving on to the SLO, or the objective. So now internally as a team, you can say, I want to create an objective that this particular system has X amount of uptime. And then once you've internally set your objectives and you've been able to start to hit them, then you can go to the rest of the organization and say, here's the SLA that we agree to, which basically becomes a contract between you and all of the data consumers to say that this data will be X, Y, and Z and have meet these particular thresholds in terms of uptime and reliability. But this is, I think, just again, I'm not inventing anything new here. I'm just saying that there's a lot of value in applying this model to the data world and spending the time to think through how it can be applied. Cool. And then another piece here that I think is helpful, a very simple metric here, thinking about data downtime. I touched on this earlier, but one way to measure that is to actually just count the number of incidents that you've had and then how long it took to detect that the issue occurred and how long it took to resolve that particular issue. We focus this presentation primarily on resolution, so the time to actually takes to resolve it, but time to detection is a big piece. And I would say that's actually the area that you likely have the most opportunity to decrease. I think from our original example here, we talked about a data consumer saying this table looks off. I see this increase in volume of this particular table. That is usually weeks late. And that can happen weeks after a particular incident has started. What we found is that if you can reduce that to hours, right? So actually to be able to detect that an issue happened within an hour, this particular data downtime goes from like days, weeks, months, it goes on and on to just a handful of hours, which is a massive improvement. And I think the beauty of being able to measure this is also internally when you're trying to advocate for resources to say we need to invest in these systems, being able to say my expectation is our data downtime today is basically a month, let's say, which is massive. If we can reduce that to a number of hours, I think any executive sponsor is going to be like, yeah, of course, that sounds amazing. That's a huge improvement. So I think these are really helpful tricks and things that we've seen work well with our customers. So we'll recap here quickly. Data, again, profiling anomalous records, evaluating the field values, so looking at the correlations, and looking for upstream data issues. So that's like our data bucket, our code bucket, looking at the actual code, did the code change? And then some kind of heuristic checks there for that. And then lastly is the operational environment. So like sequentially going through our checklist here, looking for log errors, network permission issues, performance issues, documenting our postmortems, and then defining those clear metrics. I realize that's not part of the RCA, but I think it's a helpful piece to include here within the model. Putting it all together, this is what I mentioned kind of a couple of times throughout. We spent a lot of time in Monte Carlo thinking about how to do exactly what we just described, but from a kind of in a software perspective. So being able to understand lineage, being able to understand, create these postmortems and have that somewhat be auto-documented, what actually happened in the incident, when did it start, what other tables downstream were impacted by that. All of this documentation comes together in the Monte Carlo application. And to recap, here are key takeaways. Modern data pipelines are messy. That's good. I think this is like actually one of the things that makes data so interesting is that we're empowering everyone to use data to actually manipulate, to change, to cleanse it. But it means that we have to be really thoughtful around how do we ensure that the quality stays high. This is like a really big problem, perhaps one of the biggest problems, at least that I'm excited about in the data world is solving that. RCA gives us a lot of tools. It's really about like defining a clear set of checklists. It doesn't have to be super complicated, super fancy. For the most part, if you have 4 or 5 items in your checklist, you're probably going to figure out the majority of your issues and be able to determine root cause. And breaking it down, I think, by data, code, and operational is also really helpful. It creates a clear, concise model in your head and also helps you communicate across the teams as well. So you're like, oh yeah, this was a data issue, great. But that kind of is the shared language. And of course, measurement. It's always helpful to measure. It helps you validate, helps you advocate for more resources. That is all. I really hope that this talk was helpful. It's just been an incredible experience being able to watch a lot of these talks at Coalesce, and I am so excited to be a part of it. Looking forward to the Slack chats and happy to share anything else that we've learned from our conversations. Thanks again, and have a great rest of your week.